Hi. Now, continuing from our previous step of text cleaning, where we cleaned our text of punctuation, stop words, extra white spaces. Now we have a tokenized text which is ready to be applied a prediction model upon. Um, we applied several prediction models, as you can see on the screen. Um, First of all, we divide our data set into a 80-20 ratio of training and test data set. So we build a training model based upon the 80% of the data entries and test the model to predict the star classes for the test data. So first, we need to find feature vectors based upon the unigrams, bigrams, and trigrams, and a combination of bigram and trigram and apply naive Bayes algorithms on them. So we applied several of them, namely bag of word multinomial naive Bayes, Bernoulli naive Bayes, bigram, trigram, combination multinomial naive Bayes, and random forest with 100 estimators and support vector machine (SVC) technique. So uh, we applied in the same sequence, we applied the prediction models to the data in the same sequence. Uh, and The models worked primarily on the text field of the data, and we got the confusion matrices. Um, the results were compared based upon the confusion matrices and the precision recall F1 and support measures. So all these models were applied, and the summary of the results can be seen in this slide. Uh, as we can see, the bag of words unigram model worked the best in terms of precision with the highest precision, but it had a very low support count. So considering the precision, recall, and support, the overall score of all of them, SVC performed very decent. As you can see, the performance metrics are they look to be very average. This was expected because of the free-form nature of the text and the extensive number of reviews. It was it wasn't expected that the pattern would be anything deterministic. Now, with the features obtained in the previous steps, like positive word count, the ratios, the neutral word count, like the consolidated data set, which looks like this, we tried to apply one more prediction model called the logistic regression of the GraphLab library of Python. So GraphLab is a paid library, by the way. So I worked on a free trial version of it. So um, the idea of this prediction model was to predict a net sentiment of the reviewed text based upon the number of positive words and the number of negative words. So first of all, we eliminated all the entries which had the star rating 3, assuming that they do not actually convey any kind of opinion. So on the rest of the data, we ran the model, and the results were in fact surprising. They were very good. So they were as good, the accuracy went as good as 93%. And as you can see, this is a prediction for one subset of the data. For like this is for the restaurant, Cowfish, Sushi Bar, Restaurant and Grill. So if you see the correlation between the predicted segment and the stars, you can see that um, it is efficiently predicting the positive sentiment in a review text. Now let's look at some of the interesting observations which were seen through through this entire exercise of project and coding. Uh, What you see in front of you is a list of the most frequent words sorted according to the category. So if you look at category 5, the most frequent words were awesome, favorite, perfect, cheese, area, night, and things like that. Um, Talking about positive words are like highly correlated, like directly proportional to the star rating. So you can see that the positive word count for a 5-star rating is the highest. This is expected, of course. Lastly, we try to um, um, see if we can identify a possible fake review entry. So for that, we ran a clustering algorithm on the in the R language. We ran a k-means algorithm with 5 centers, and these are the clusters which we obtained. So let me bring it in scope for you. So if you look now, it's a 3D plot against the review stars, the business stars, and the negative word count. So if you look at this, the business rating, the business which is rated as is generally rated as a 5 or a 4. It has some outliers here, which has a very high negative word count. So uh, we identify these as a possible candidate for fake reviews, and these are the entries which require further uh, investigation. So, finally, as a conclusion, I would like to say that we established relationship of features like review text, positive words and negative words, and review count with the user review star ratings. We found a positive correlation between the average user review stars and the business ratings. And for future work, uh, we can build a personalized recommender model for restaurants for users, and we can work more in the fake review classification. Thank you.